Once again, good morning to you all. You're all very welcome to today's nQuery Advisor and nTerim 2.0 upgrade workshop. My name is Eoghan Murphy. I'm a statistician here with Statistical Solutions. In fact, I was part of the team that developed this latest release of nQuery and nTerim 2.0. I'm joined today by my colleague, Andrew Grannell. Andrew is the senior statistician here at Statistical Solutions, and Andrew has kindly agreed to field any questions you might have throughout today's webinar. So if you do have any questions, or indeed if you have any comments or feedback on the software, you can ask them by typing them into the chat box on the right hand side of your screen. Now I would say just bear in mind there are quite a number attending today's webinar, so we may not get around to answering all your questions during the webinar, but however, if all your questions will be logged and we'll endeavour to get back to them within 24 hours of the webinar ending, generally within a few hours of the webinar ending. Okay, so just before we begin, if you find that your screen is maybe too small or even too big, you can adjust the size of your screen using the drop-down arrow again on the right-hand side of your screen. Alright, so let's get started. So this is just an outline of what I'll be going through in today's webinar. This workshop is to coincide with the new release of nQuery and nTerim 2.0. So to begin with, I'll first detail some of the new features and the tables on offer in this new release. I'll then go on and quickly go through the steps involved in sample size determination. And then, following these steps, I will demonstrate how to calculate sample size and power using nQuery and nTerim 2.0 for both fixed and group sequential trials. Then, as well as I say, if we have time at the end, we'll answer some of your questions through the webinar. But if not, as I say, we'll just send them in anyway and they will be answered within 24 hours of the webinar ending. So keep sending in your questions and any comments that you may have. Okay, so nQuery and nTerim 2.0, what's new? Well, in this new release we focused on three areas. We asked ourselves what additions we can make to our tables for sample size calculation. We also looked at if you could include some new features to even make the software even more intuitive and make it even easier and quicker to use. We also then asked ourselves what we could do to improve upon our plotting options. Are there any plots that we can add to our current plotting options, or are there any features we can add to our current plots that would again make things easier, again more intuitive for you guys, the users, to use. Okay, so for our new tables, we have we've made additions to both our fixed term and our interim or group sequential sample size tables. As you can see here, for some of the fixed term tables, we have repeated measures for two means, two proportions, multivariate analysis of variance, analysis of covariance. And then for the group sequential, what we've done, we've added some early stopping for futility for our group sequential tables. With the new features, again, like I say, these features were included to make the software more intuitive and easier to use. Now, it's not possible for me to list all the new features here. So what I would do, I'd strongly advise, maybe even encourage all of you to take a free trial of the software after this webinar. I think this will help you to get a feel for how easy and intuitive it is to use and how to run power and sample size calculations in nQuery and nTerim 2.0. So just quickly running through some of the new features here. What I've said here with it's being fully integrated. Now, what this mean by this is that nQuery and nTerim 2.0 are now fully integrated together. So there's an option for you to pick either a fixed term test or an interim test. Now, for the rest of the features that I've listed there, when I'm demonstrating the software, I think these will be quite apparent. So just for the new plots, what we've done here, we've improved upon our power versus sample size plot. We've kind of added in a slider. We made the plots. We've added the editing features within the plots, so you can now add legends and edit your legends and edit your titles. We've also then, for our group sequential offering, we added an additional boundaries plot and added in a spending function plot. Okay, so as I say, keep sending in your questions or any comments you have throughout the webinar, and we'll answer them during the webinar, and if not, we'll get back to you afterwards. Okay, so before I begin demonstrating some examples of sample size calculations in nQuery and nTerim 2.0, I will first go through the steps that are involved in sample size determination, as this is how the sample size process in nQuery and nTerim 2.0 is structured. So at the beginning of a study, you might ask yourself, well, what sample size do I need? Now, we view this as this question as being the answer to this question as being a 6-step process. The first step being, how do I formulate your study? What I mean by this now is to formulate your study, you need to detail your study design. So you set out each step in your study, what it is you're studying, what you hope to achieve by your study. You then need to choose what the primary outcome of your study is going to be. So you need to look at maybe, are you looking at the mean change in groups after a treatment or after a drug has been administered. Then having formulated your study, you need to specify your analysis method. So what is the most appropriate test for you to use for your study? The second step then is to specify your analysis parameters. Your analysis parameters, what I mean by this here is that these are the significance level that you want to set for your study, and you also need to specify whether it's going to be a 1- or 2-sided study, etc. So again, for a third step, you need to specify the effect size for a test. So you need to ask yourselves what it is you're looking for in your study. Are you comparing previous results with this product? Are you comparing previous results with similar products? Essentially, what you need to do here is you need to specify what the beneficial effect of your study is going to be. Or for the fourth step then, you can then, having specified the followed steps 1, 2, and 3, you can then calculate either sample size or power for your study. Then in the fifth step, we would see this as being running a sensitivity analysis. So once you've identified the parameters you want, there are certain parameters, we'll say, in the effect size parameters, which you might not be sure of. You still need to maybe have a range of sample size or power values for these parameters. As these parameters move, you need to see how the power and sample size adjust. And finally, once you're happy with your setup, you choose your sample size and you write your statement. Okay, so we'll have a look at the software and we'll run some examples demonstrating following these 6 steps, how to calculate power or sample size using nQuery and nTerim 2.0. Okay, so when you open nQuery and nTerim 2.0, this is the window that you will see. Now here, what you see, this is the study goal and design window. Now this window is for step 1 essentially, is to help you formulate your study. This is purpose of this window is twofold. The first is to help guide you in your test selection, and the second is to help you find the relevant test quickly, because there is such a large number of tests available in nQuery and nTerim 2.0. Okay, so for our first example, say we're looking at comparing means in 3 groups for a fixed period design, and we want to test if there's a difference in our groups. So after formulating your design, you find that you need to do an ANCOVA test. So you want to do a fixed term test, and your goal is you're comparing means, and the number of groups is going to be 3 groups, so you select greater than 2, and you're testing the difference, so you select test. And for your study, you want to do an analysis of covariance, so you can see analysis of covariance here at the bottom. And now just a quick note here on the interface of nQuery and nTerim 2.0. You'll see here we have the spreadsheet style interface here, so where you can enter values and edit values as they appear in your table. Also on the right hand side here we have the guide cards, which help guide you in what values you should be entering, and help guide you in with the range of values and give you input advice and entry options, and also the references for the test. So as you see, as you move down the table, the guide card updates on the right hand side. Okay, so the second step after we formulate our study and we choose an ANCOVA design is to specify our analysis parameters. Now for the ANCOVA table, the analysis parameters are alpha, or significance level, the number of covariates, and the number of groups. So for this design, we're going to set a significance level of 5%. And we'll set for 1 covariate. Okay, so the next step then is to specify the effect size for the test. So the effect size here, we need to specify the variance of means, the common standard deviation, and the R-squared with covariates. Now, for the variance of means, we have an effect size assistant here at the bottom of the screen. So here you can enter in your values or your means for the three groups. And so we're setting equal sample size per group. Once you're happy with your inputs, you can click transfer, and these values will then transfer to the table. So we now specified our effect size for the test. We specified our effect size parameters. So the next step that we want to do now is decide whether we're going to calculate sample size or power. Or for this example, say that we're restricted to a sample size of 80 participants. So you type in a sample size of 80, and we probably estimate our cost per sample size as being, we say, 150. So you can see here the total study cost is automatically calculated for you based on your sample size and your cost per sample unit that you've entered. So the next step now we want to do is calculate the attainable power with our given sample size. So click run, and you find that your power is 96.98%. So what you can do here, you can do a plot of power versus sample size by clicking the button at the top there. So you can see here again, plot of power versus sample size, move your slider along. Actually what it tells you here is it gives you the power and sample size on the bottom right of your screen. And also what's given here is the output statement for the column. So having done this now, the next step, as you say, is the fifth step, is to do a sensitivity analysis. So what we want to do here, maybe we're a little unsure about our values for our standard deviation or our R-squared, so we look at maybe a range of values. So we're going to look maybe at a standard deviation of 5, 6, and 7, so we can enter just a list of values here in the specify multiple factor table, which helps you do this very quickly. So if I want to look at maybe a range of values from 0.4 to 0.6 in my R-squared, and I look at that in increments of 0.1. So once I'm happy with my setup here, I can click fill, and the table then will automatically fill with every possible combination of the values that I've entered here. So if I want to keep my significance level, my number of groups, my variance means constant, I can just highlight these and click fill right. So this fill in here. So you see now I've very quickly set up over 10 analysis here very quickly just by using the specify multiple factor table and the fill right option. So what I want to do here, I want to do for all columns, I want to calculate the attainable power with the given sample sizes that I've entered for my test selection. So by clicking run, the value for power for each analysis is done very quickly for you. So in a matter of moments we've done very complex calculations here very quickly, very quickly for you. Again, the output statement at the bottom here updates as you move through the columns. But say for instance you want to compare the power versus sample size for, we'll say the standard deviation, the plots with the standard deviation of 6. So you can just highlight the plots with the standard deviation of 6. So you see 6 here in each plot. And you can look at the plot of power versus sample size for these 3 plots. So you can see here the 3 plots are plotted together. We're going to change the title so we'll know it's for our own references that it's a standard deviation of 6. You can also enable a legend here on the right hand side. So column 2 was the R-squared of 0.4. So you now have our plot of power versus sample size for standard deviation of 6 for R-squares of 0.4, 0.5 and 0.6 comparing against here one another. Now what you can do here is you can copy this and you can just copy and paste it into a Word document very quickly. You can also grab the output statement, so if you want to save this first you can just drop it down here, so it'll be stored here and clicked in here. So your output statement here, you can also just quickly copy this and paste it in. So your report is generated for you very, very quickly here using nQuery and nTerim 2.0. Okay, so say now you want to maybe look at doing another test. You maybe thinking of changing your study, doing a different study. And for this study, maybe you want to look at doing, we'll say, a difference in two means using an interim design. So if you want to open up an interim study here, you can just click one of the buttons here on the top, whether it's be a fixed term or an interim design. So if you want to click on an interim design, here you click an interim design, we're looking at means, two groups, and we're going to do tests. So we're going to do a group sequential test of two means. So again, this is step one here. We're formulating our study using the study goal and design window. So here now you'll see the interface here is very similar to the fixed term test, which we have the spreadsheet style interface and the guide cards on the right hand side here. But the addition here is that we have a looks table at the bottom here of the screen, and also a boundaries graph, which when the information is inputted and run, the calculation is run, will fill up and produce the boundaries graph for this looks table here. Okay, so again, the second step in your study is to specify your analysis parameters. So specifying an alpha level of 0.025. Third step, specify the effect size parameters. So let's type in our values here. Now for this study, I want to calculate the sample size for a given power. So I just type in the power of 90%. Now for group sequential trials, you must do an additional step here. You must input your looks information, your group sequential, your interim, actually analysis information. So for here, you would just specify your number of looks. We'll keep this at 5. How the looks are spaced, and what boundaries you want to use. So there's a selection of boundaries here for you to choose from. The O'Brien-Fleming, the Pocock, the Power Family, and the Huang-Shi-Dekani. So for this example, we're going to do this O'Brien-Fleming calculation. So again, once you're happy with your setup, you want to calculate the required sample sizes for your given power. Simply click Run, and the calculations are done here for you. Now, as I say at the bottom here, you're also given additional output here. So you're given the looks information. You're also given the boundaries graph here on the right hand side, which plots this looks information. So it plots the Z value at each step. As well, there's an output statement given based on the information above. But again, what you need to do here, you need to do a sensitivity analysis. So we'll say here, for this example, you're happy with your input parameters, but you want to change, maybe you want to look at see what happens if I maybe change my spending function. So you want to compare the spending functions effectively. So again here we want to look at maybe doing the full range of spending functions. Power family and Huang-Shi-Dekani. Now for the power family and the Huang-Shi-Dekani, you must specify this phi parameter. Now for the power family, this phi parameter, when it's equal to 1, it's very similar to the boundaries from the Pocock method, and when it's equal to 3, it's very similar to boundaries from the O'Brien-Fleming method. Similarly then for the Huang-Shi-Dekani, when phi is equal to 1, then the boundaries are very similar to the Pocock method, and when phi is equal to -4, the boundaries are very similar to the O'Brien-Fleming method. This information, as you can see here, is given here in the assistant on the right hand side here in the guide card. So we're just going to set our power phi for as 2.5 for both. Can we calculate our required sample sizes for each column? So you can see here how the sample size differs depending on which spending function you use. So as you move between the columns here, you can see how the spending functions are plotted here on the right hand side and the bottom right. But you can also, if you want to compare all these spending functions onto one plot, you can do this by selecting each one. So you have here our spending function plot. Again, we enable our legend. So you can see here the O'Brien-Fleming is a lot more conservative at the start compared to maybe the Pocock, which is quite uniform. So again, you can just snap this in here, up here on the right hand side. So if you're happy, we'll say, with your O'Brien Fleming, because you want maybe select the O'Brien Fleming because it's more conservative to start, you can also see, well, what if you might ask yourself, what if you entered in some futility boundaries? How will that impact on the sample size? So you want to compare how the sample size is for, say, adding in either a non-binding futility here. So again, at the end, we can add in our futility boundaries. So for column 5 here, we're not going to have any futility boundary. We're just going to leave it as is with an FXC boundary. For column 6, we're going to add in a non-binding futility boundary. And for column 7, we're going to add in a binding futility boundary. So again, just click Run to calculate the required sample sizes for each column. So immediately what you notice here first, before even looking at the sample sizes, is that here for column 5, which is just the efficacy boundary, we just have the one plot of the data points here. For column 6 here, we also have our futility boundary added in here. And similarly for column 7. So what you want to do here now, you want to compare the power and sample size for these. So again, highlight your columns, you can click Power versus Sample Size. So here we get a plot of power versus sample size generated for you. So you can see here very close there in relation to the power and sample size as they go up along. And this is reflected in the values that are outputted here. So again, for column 5, which is you can see that the power value and the sample size are less. The required sample size is less for a given power in column 5, which is our efficacy boundary. You can see here then, as you move on, as you add in futility boundaries, that the sample size requirement increases. So again, you can store this plot here. And you can also maybe, if you're not happy, what we have here is we have an inverse boundaries plot. So again, this inverse boundaries plot is just a different way of looking at your boundaries information. So if you wanted to go with we'll say a binding futility boundary, so you select column 7, and it gives you an inverse boundaries plot, which is just a different way of representing the data for the test. So again, you can copy all these plots just by right-clicking copy, and you can copy into a Word document very quickly. You also have your output statement here for all columns. It's generated automatically for all columns, so as you move between the columns, the output statement updates for you as well. Okay, that's about all I have to show for you today on our workshop demonstration today. If you do have any questions, please send them in, or any questions at all, any comments on the software, please send them in. We'd be very happy to hear from you. Okay, so thank you very much. Okay, so we've quite a number of questions flooding in here. Again, thank you very much for your comments. All the comments and feedback seems very positive so far. Again, you're getting some great questions coming in. We've only time just to answer one. But as I say, keep sending in your questions. But Andrew and I will be online for the next few minutes anyway, and we'll be answering questions as they come in. Again, as I say, if we don't get around to answering your questions within the next few minutes, then we will, as I say, answer them within the next few hours. Okay, so there's one person asking there very quickly, what's the difference between the inverse boundaries graph and the boundaries graph? Essentially, they're plotting the same data. With the boundaries graph here, what you have is that the continuation region is shaded. So if your test statistic remains within this region, within the shaded region, then your test will continue. Otherwise, what we have here, just in comparison to it, is the inverse boundaries graph. So what you have here is that the stopping regions are shaded. So if your test statistic goes above this region, goes above this line here, the blue line, goes into the blue region, then you could say that there's overwhelming evidence of efficacy and you can perhaps stop the trial. Now, this is rarely done in practice, because if you got efficacy showing in your trial, then you're going to want to continue your trial just to show how great it is, essentially. Perhaps more importantly, what you have here is that in the red region here at the bottom, so when your test statistic drops into this region, depending of course on your trial, but if your test statistic drops into this region, then it is showing that your trial is effectively futile. That is, you will not see a beneficial effect using this trial, so you can help you to stop your trial early. So again, just to summarize, the inverse boundaries graph and the boundaries graph are plotting the same data, but they're just they're different ways of representing the data. Okay, so once again, just thank you all very much for your time and for attending today's webinar, and indeed all your questions and your comments and your feedback on today's demonstration. As I say, just keep sending in those questions, and we will answer them over the coming few minutes. And again, if we don't have time to answer them, we will answer them within 24 hours of the webinar ending. Okay, so once again, on behalf of Andrew and myself, thank you very much for your time. It's been lovely demonstrating for you.